Today we are here to discuss the Bridgeton Project corridors, beginning with Atlantic Street corridor analysis. Here's a closer aerial view of the Atlantic Street Project corridor, which ends at Vine Street to the north and Harvard Avenue to the south. The Atlantic Street corridor has an average daily traffic of over 1,800 vehicles and has a posted speed limit of 25 miles per hour. There is no existing or proposed bicycle network within the project corridor. However, the 2015 Cumberland County Bikeway Inventory lists Water Street as being conducive to a future bike network, as it would provide connectivity to an existing bike trail located on an abandoned rail spur southeast of the project corridor. For discussion purposes, it is important to note the proximity of this network to Atlantic Street. The Atlantic Street corridor is comprised of predominantly low-density residential. The corridor is also partially located within the Glenview Historic District. This creates a quiet residential character to the roadway. Looking at the roadway from a crash data perspective, we can see that crashes within the project corridor are concentrated at 4 locations within the project limits. These hotspot clusters of 6 or more crashes occurred in proximity to intersections, but not within them. Looking at the number of total crashes within the project corridor by year, we can see that the number of total crashes annually are fairly consistent, averaging about 10 per year. According to the data-driven network screening analysis, Atlantic Street corridor was the second-ranked road segment on the high-ranking crash severity list for Bridgeton. In addition, the intersection of Vine Street and Atlantic Street was the second-ranked intersection on the crash severity list in Bridgeton. While it may be hard for some to believe that a quiet residential street with such low traffic volumes could be this dangerous, the data shows otherwise. 5 of the 54 total crashes on Atlantic Street were pedestrian or cyclist related. This represents almost 10% of the total crashes within the corridor. This high percentage of bicycle and pedestrian crashes contributed to its ranking as the second highest corridor on the crash severity list in Bridgeton. We can see from the crash data that 4 out of 5 pedestrian crashes resulted in some degree of injury. Taking a deeper look into the crash data, we can know crash characteristics, paying particular attention to lighting conditions and location. Crash data showed that 1 out of 3 crashes that occurred in a dark and unlit area involved a pedestrian. Furthermore, 40 of the 54 total crashes did not occur at intersections. However, data can only provide so much information. On December 11, 2019, a multidisciplinary team of local, state, and regional agencies conducted a pedestrian bicycle-focused road safety audit of Atlantic Street. This event helped to confirm perceived safety issues while also providing a greater context. This event also allowed for a multidisciplinary team to assess the corridor and provide their recommendations for solutions to found issues. This process led to the following findings. The major contributing factors for crashes in the Atlantic Street project corridor was unmarked crosswalks, vehicular traveling speeds, and inadequate lighting. Safety improvements. Crash data from the New Jersey Department of Transportation's Safety Voyager database shows that the 3 major crash types within the Atlantic Street corridor are struck parked car, right angle, and pedestrian. Representing 61% of all crashes within the corridor, struck parked car was the most prevalent crash type within the project corridor. Why is that? What we found through crash data and site visits was that roadway users struggled to see parked cars. Users also struggled with gauging their travel path within the roadway due to a lack of pavement markings. Consistent throughout was the motorists were often traveling above the posted speed limit of 25 miles per hour. Edgeline stripings reduce the optical width of the roadway and delineate pavement use between parking and travel. Atlantic Street lacks lane delineation in its existing condition. This creates a drag strip effect where motorists knowingly or unknowingly increase speed. Edgeline stripings have seen a positive effect of up to 24% in reducing crashes on similar road types. Residential street lighting increases the visibility of the roadway and the roadway users. Poor visibility is a safety hazard for all roadway users, particularly pedestrians and bicyclists. Upgrading existing lighting and/or adding new lighting have decreased nighttime crashes by up to 50% on similar road types. The second most prevalent crash type in the Atlantic Street corridor was right-angle crashes. We found speeding to be the general cause for this crash type. Speeding vehicles increase the possibility of right-angle crashes at unsignalized stop-controlled intersections. As motorists cross Atlantic Street, are not given enough time to safely clear the intersection, or are not seen by approaching motorists until it is too late. Speeding not only increases the likelihood of crashes, but also the possibility of crash injuries. Pedestrians hit at 40 miles per hour are 4 times more likely to result in serious injury or fatality than at 20 miles per hour. Research has also shown that the higher the traveling speed, the smaller the cone of vision for motorists. Furthermore, the faster the motorist travels, the larger the stopping distance required to slow the vehicle. To improve safety within the Atlantic Street corridor, it is imperative to manage traveling speeds. Semi-permanent speed cushions are an excellent tool for speed management. They can be installed in the roadway and easily moved as needed. Studies have shown that speed cushions effectively drop crossing speeds to 10 to 15 miles per hour. Speed cushions are also designed with first responders in mind. The slots between the cushions allow for first responders to cross without slowing down. The third most prevalent crash type within the corridor was pedestrians. We found the general cause for pedestrian-related crashes to be speeding vehicles, poor visibility, and lack of marked crosswalks. However, different than other crash types, pedestrian crashes within the Atlantic Street corridor predominantly occurred at the Vine Street intersection. As previously mentioned, the Vine Street intersection was ranked as the second highest intersection for crash severity in Bridgeton. Currently, the Vine Street intersection is stop controlled on its east and westbound approaches, while traffic flows free on Atlantic Street north and southbound. Motorists traveling north and southbound on Atlantic Street are often hard to see from the east and westbound approaches. The speed of the free-flowing traffic, the lack of visibility caused by sight obstacles and parked cars creates safety issues. Making this intersection a four-way stop will address these safety issues and make the intersection safer for not only motorists, but also bicyclists and pedestrians. The intersection of Vine Street and Atlantic Street does not include any marked crosswalks. High visibility marked crosswalks indicate optimal or preferred locations for pedestrians to cross the road and establish right-of-way between motorists and pedestrians. In contrast to basic crosswalk markings, which consist of 2 transverse lines, high visibility crosswalk markings present a zebra-like pattern. This pattern is more visible to oncoming motorists and helps to highlight the crossing location, discourage drivers from encroaching into the crosswalk, and reinforce the driver's requirement to yield to pedestrians. High visibility crosswalks are shown to reduce pedestrian crashes at intersections by up to 40%. Proper crosswalk lighting is necessary to ensure that the improved marked crosswalks are properly lit during dawn, dusk, and dark conditions. Proper street lighting has shown to reduce pedestrian crashes by up to 59%. Curb extensions have also been proposed at this intersection to not only increase the visibility of pedestrians, but also approaching motorists. Curb extensions reduce the crossing distance for pedestrians while reducing the speed of turning vehicles. Curb extensions, also known as bump outs or neck downs, reduce the effective street width at pedestrian crossing locations by extending the sidewalk and curb line into the parking lane. Curb extensions help to improve safety by reducing pedestrian crossing distances visually and physically narrowing the roadway, improving visibility between pedestrians and oncoming motorists, and preventing vehicles from illegally parking in or near crosswalks. Curb extensions shield on-street parking at the intersections and do not reduce parking supply. Installing a curb extension is often referred to as daylighting an intersection due to its significant improvement in visibility. As shown in this example, curb extensions increase the overall visibility and safety of an intersection by also increasing the visibility of signage. This reduces the likelihood of a motorist running through a stop sign,